Okay, now that you actually know that refraction is the bending of light, and we know that more optically dense mediums will bend light more, it would be really great if we could actually quantify that with a number. And we can. It's known as the index of refraction. So every different medium has a different index of refraction. The larger the number is, the more optically dense that substance is, meaning the more it will bend light. So let's look at our different substances we looked at before. We know that the least refractive was air in a vacuum, and the index of refraction for air in a vacuum is 1. Now water, slightly more optically dense than air, it has a refractive index of 1.33. Glass is more optically dense than water, so it slows the speed of light down more. Its index of refraction is 1.52. And diamond, the most refractive substance, the most optically dense substance, the substance that speeds light down the most and will bend light the most, 2.42. Now, how do we calculate the index of refraction? Well, it's easy. The index of refraction is actually equal to the speed of light in a vacuum divided by the speed of light in a material. So let's do an example problem. So here's our first example. The speed of light in a liquid is found to be 2.25 times 10 to the 8 meters per second. What is the liquid's index of refraction? So anytime we're doing any physics problems or word problems in math, we always start by writing down what's given. The first thing we're given in the problem is the 2.25 times 10 to the 8 meters per second. That's the speed of light in the liquid. Now, it doesn't seem like we're given very much, but remember, we do know what C is. C is a constant value. It's the speed of light in a vacuum, and it's always equal to 3.0 times 10 to the 8 meters per second. Now, what we're trying to solve in this formula is the liquid's index of refraction, or N. So that's what we're required to solve. The next thing that we're going to do is actually start with our formula and start subbing in our values and actually solving it. So we're going to start with the formula N equals C over V. So let's sub in our values for C and for V. Now note, meters per second divided by meters per second, we can cancel this. 10 to the 8 divided by 10 to the 8, we can also cancel this. So all we're left with is 3 divided by 2.25. Now if we do this, you should get 1.333333 on your calculator. How many 3's do we keep? Well, this is where significant digits come in. Now you would think we're going to look here and you might think you want to take 2 significant digits because C is equal to 3.0, but don't be fooled. C is a constant value. It's the speed of light. I could have written it as 3.0 times 10 to the 8. I could have written it as 3.00000 times 10 to the 8. It's an exact value. It's a known value. So we're not going to be concerned about the significant digits for the speed of light because you could have written anything. What we are going to be concerned about is this significant digits in our other number, 2.25 times 10 to the 8 meters per second. Now, in this case here, there's 3 significant digits. So we need to have 3 significant digits in our final answer. Look to the right to round the number properly. In this case, it's a 3. 3 is less than 5, so we're going to leave that last digit alone. Therefore, our final answer is going to be 1.33. Now, the last thing we have to do with physics problems or word problems in math is restate our conclusion. So we're going to paraphrase it. Therefore, the index of refraction of this liquid is 1.33. Now, please note, there's no units for index of refraction. They canceled out. And that's what you should have. The index of refraction is known as a dimensionless value. There's no units for it. So if you are getting units, when you do your math for index of refraction, go back and check your formula because you probably have it set up wrong because you shouldn't get any units in your final answer. Okay, let's do a second example. In this case, we actually have to solve what the speed of light is given an index of refraction. So again, write down what's given. We know N is equal to 2.98. And don't forget, we know that C, the speed of light in a vacuum, is 3 times 10 to the 8 meters per second. We are required to solve the speed of light in the plastic, so we're trying to solve V. So we're going to start again with our formula, N equals C over V. Now we're going to reorganize our formula to solve for V. So V equals C over N. Now we can actually just sub in our numbers and solve our equation. Now, we don't have times 10 to the 8 meters per second here, so that can't cancel. We actually have to do the numbers, but don't worry, it's not as hard as it looks. We're still going to divide 3.0 divided by 2.98, and you should get 1.00671140939, depending on how many digits your calculator has. Now, notice I still have times 10 to the 8 meters per second. I actually just carried that down. I had nothing here to cancel it, so I just left it. Now, when we did this, we still got a number between 1 and 10, so I could leave my exponent as times 10 to the 8. So just make sure you use scientific notation rules. So I have my number here, but I am not done yet. I am still missing those important significant digits. Now again, don't be fooled by C. C is a constant exact value. It's known. So I'm not going to worry that there's only one number written here for C. What I am worried about is those 2.98, the index of refraction. And that has 3 significant digits. So my final answer down here needs to have 3 significant digits. I'm going to look to the right, and it's a 6 in this case. Now 6 is greater than 5. So what I'm going to need to do is round that last significant digit up 1. So my final answer, 1.01 times 10 to the 8 meters per second. Last but not least, because it's a word problem, in physics we need to paraphrase our statement. So therefore, the speed of light in this plastic is 1.01 times 10 to the 8 meters per second. Now, if you needed any help with figuring out the significant digits, reorganizing the formula, or rounding, make sure you check out those math help videos and come see me for extra help as well.